Howdy everybody, this is your next video. This is for chapter 24. We're talking about mean differences versus the difference in means. So I'm going to try really hard to explain it, and hopefully it works, and whatever is making you confused, bring it to class next period, or text me if you need some help at home. So on the left here, we have the outline for difference in means. So, we've talked in school about the difference between men's and women's ages in a marriage. We've talked about, what we've talked about. Anyway, so when we talk about a difference in means, we're saying I've got an independent sample and another independent sample, and I want to know if there's a difference between the means of these two independent samples. So that's the biggest issue that we have to tackle, is that I have two independent samples. Now, the other one that we're learning about now is mean difference. With mean difference, we have paired data. In other words, two pieces of data that go to an individual element. So, for example, the inner and outer lane of a ski race. So the ski race is your element, and the inner and outer lane are the paired data. What about gas mileage? Gas mileage on Monday and gas mileage on Friday. Well, if it's the same car, so if the car is the same, then the difference between Monday and Friday can be compared because it's the same car. The element is the same. So what do the questions look like, and are there hints as to how we can separate them? Well, let's talk about skiing. Are average slalom course speeds different on the first and second run? So what I'm talking about is the course. I'm talking about the slalom course. So because I'm talking about the slalom course itself, I want to know about the first and second runs on a slalom course. Now, when I'm doing this, it doesn't mean I'm looking at just a single course, not a single slalom course. The question is implying that I have a variety of courses that I'm looking at, and I want to know if the speed on the first course is faster, slower, different than the speed on the second course. So my null hypothesis is that the speed on the first course and the speed on the first run and the second run are going to be the same, and my alternative hypothesis is that they're going to be different. Would I pool? No, because when I'm testing means, I don't pool. That's only for proportions. On the other hand, I have the question worded similarly but different. Is there a difference between mean run times of slalom skiers for their first and second runs? So here my element is not the course, my element is the skier. And I want to compare the skiers' first and second runs. I want to see if there's a difference in times. So for each skier, there's a pair of information. There's their first trip down the mountain and their second trip down the mountain. So here, I'm no longer comparing means, because I'm not going to compare all of the skiers' first runs to all of the skiers' second runs. I'm looking at each skier's individual times to see what the difference is. So how I'm going to notate that is mu difference. What is the mean difference between their first and second times? Not what is the difference between the two means, first, second run. I want to know the mean difference between their two times. So what I've done is I found some current data about slalom racing. And what we have here is, this is their birth year, by the way. Makes me feel old, whatever. First run, second run, overall time. So what I can do with this data is I can look at this data and say, okay, is there a difference? And remember, we're talking statistically significant, not an eyeball difference. Obviously, I can see there's an eyeball difference between these two values. But is it statistically significant? Does it really matter? So I've got my first set of data, I've got my second set of data. These data are paired because it goes with the same person. This is Miss Bell's first and second run down the hill. So since it's the same body doing the run, this data is paired. So I'm going to grab my data and I'm going to dump it into Mr. Calculator. So I have the first run here. I have the second run here. And in my third column, what I'm typing in is L1 minus L2. That will give me the difference in their times. And I hit enter and you see that my values are the same. When I do this, I find that the average for the first run is 29.644 with a standard deviation of 1.599. The average for the second run, 29.821, standard deviation 1.784. And then for the third run, for the mu difference, so for the mean difference, on average, the difference between the first time and the second time is negative 0.177. And we'll talk about interpreting that negative here in just a second. And a standard deviation of 0.509. Here's one of the biggest difference. If I'm doing a difference of means test, so if I have a difference of means and I have two independent samples, right? Then I'm going to do a two-sample t-test. However, if I'm doing mean difference, I now only have one set of data. I have the list that's the difference. So I'm only going to look at this one column of data. So I'm not going to do a two-sample t, I'm just going to do a t-test. I go to my calculator. I go to tests, good old t-test. Since I have the data in there, I leave the data in there. So how do I want to set up my null hypothesis? Well, I want to say that my mu d is 0. I'm going to use list 3 because that's where my differences are. And then I'm going to say that my observed differences are different than 0. That's what I'm checking for. And now I'm going to calculate. And you see that we have our t-value, our p-value, our bar x, and our sx. Then, of course, we're going to come up with the question of how do I interpret this? Well, check out my p-value. It's 0.215. So with a p-value so large, I fail to reject the null hypothesis. My null hypothesis is that the mean difference is 0. So since I'm failing to reject my null hypothesis, I have evidence that there's not a difference in speed between the first and the second run. So even though there's numerically a difference, so even though there's visually and numerically a difference, statistically, it's not. So the average speed that skiers go on the first run and the average speed that a skier goes on the second run isn't different. It seems to be pretty darn consistent. Now let's talk about that negative. In the calculator, like I said, I did L1 minus L2. So if I get a negative value, that means L1 was smaller than L2. If my overall average difference is negative, that means for the average skier, their first run was faster than their second run. That's just a way to interpret that negative right there, and we'll talk a lot more about that in class. It's really kind of nifty. So let's take a step back and say, okay, All right, Miss Meyer. So, is there a difference between mean run times of slalom skiers for their first and second runs? Definitely paired data because I'm talking about a skier, their first and second runs. It's mu d. Let's talk about the slalom course. If I look at my data and I say I've got the data, the average time of 14 different slopes. I've got the average time of 14 different courses. So my L1, now remember this is hypothetical. I don't actually have the times. So my L1, these values represent the hypothetical average speed of the first run on a slalom course. These are the hypothetical average speed of the second run on a course. So now I'm not pairing the data together this way because each one of these columns represents a first run and a second run. Okay, so they're not paired together. We have two independent samples. If we go to stat test, we would do a two-sample t-test, and we'd input L1 and L2, and we would check to see that they are different. So not equal. We don't pool. Let's calculate. And check out the weirdness that this gives us. So we get our t-value, good enough. We get our p-value. Wow, look at how big that p-value is. With a p-value so large, I definitely fail to reject the null hypothesis, and I have evidence that the average speed on the first and second run of a slalom course is the same. So on average, for everyone who went down that mountain, their speeds are going to be the same. Check out my degrees of freedom, though. That's what's weird. I had 14 pieces of data for column 1. I had 14 pieces of data from column 2, but somehow wound up with a degree of freedom of 25.696. Remember that awful formula I showed you in class? That's where it comes from. So since our calculator is going to give it to us, we don't have to find that by hand, thank goodness. Bring any questions you have to class, and we're going to spend more time talking about how to differentiate when it's a difference in means versus a mean difference.